Any questions, guys, so far about this? The material, the exam.
بس دكتور أنا رح أقدر أحضر بس 30 minutes لأنه عندي صفحة 3:30.
Yeah, no problem. I mean, now I'm gonna do this, but when it usually works for you guys, does it work later? Like 6 or 7 maybe?
لا دكتور بري ريكورد بتنزله بنفس النهار على اليوتيوب بيكون تمام يعني بفوت دغري بس أنت عم تتأخر باللكتشرز يعني في كذا ما بعرف.
Yeah. Some of them I've had problems with uploading them, and now I don't have any problem with basically uploading that anymore. So all these lectures will be basically posted right after that we actually recorded. This is what is gonna happen now.
So هلا نحن هنعمل example 6 دغري بعد ال 5 اللي عملناه last time آخر مرة.
لا هلا رح نعمل example. هذا example ما عملنا ال5 بعد. Okay.
مزبوط ما عملنا ال 5.
Okay, let me just see if. Okay. Okay, guys. All right, let's go ahead and then start by doing this for example. So here, what we have is basically we have a car that is traveling along this parabola, and just a second, let me just set this up like that. Okay. So we have this car traveling along this parabola, which is given to us as 20 multiplied by 1 minus x squared over 6400. So we have that. So I'm gonna draw it here. So this is what we have, and this is my x, and then that is my y. And basically I have this guy given to me as y is actually a function of x. All right. And we know the weight of the car. What is the mass of the car in this case? It is 0.8 megagram, right? So which is 800 kilograms. Okay, and the car is going with a constant velocity along this. So the car is traveling with a constant velocity along the slope. And what we would like to do is we would like to actually find out the resultant normal and frictional force on the car at point A. So at this point A. And at this point, basically, we have 80 meters. Okay, so I need to actually do that. Can someone help me to draw a free body diagram here on the car at A? How does the car look like? So this is point A, let's say, right? And then this is a car. Okay, I like this representation of the car. All right, how can I, so I need to put this, and on this diagram, I'm gonna put what? I wanna put my acceleration. Okay, so here forces, and then here inertial forces or accelerations. All right, what should I put on the forces?
We have the normal force.
Okay, the normal force is gonna be how?
Perpendicular to the surface.
Perpendicular to the tangent, right? Exactly. Perpendicular to the tangent. This is a normal force. You guys all agree?
Yes, doctor.
Okay, what else do I have going here?
The weight.
The weight. The weight has to be at the center of gravity. And that's it. We have mg. Anything else, or do we have any frictional forces or no?
Yes, we have friction.
We do. The car is going at a constant velocity, مظبوط. If you are letting go of the brake, the car may accelerate even more, مظبوط, or maybe accelerate even less. So to force something to go into a constant velocity going downhill, ما هيك, you have to have a balance of the forces. So here, how does the friction force look like?
It's to the back, opposite to the movement.
Opposite to the movement. Bravo. So this is my friction force. What is the friction force? Is it going to be equal to mu k times n or no?
Yes, because it's moving.
let's move on. Mk times n.
Shouldn't we find the like y component of n, doctor?
لا خلص انا هاي I have the n normal force is perpendicular to the tangent. I'm
Ah,
good.
okay.
هون the friction force basically هون is it sliding? Does your wheel slide? If your wheel slide then yes, but if the wheel is not sliding then لا. The friction force is Mkn if you have a sliding movement. مش هيك؟ بس the wheel rolls basically, right? It
هلا
rolls.
sliding هلا
It rolls, right? The wheel it rolls basically. We'll actually look into the frictional of rolling movements later. بس هلا هون there is some friction force basically applied on the actual wheels more than anything else. All right. How about here? What do I have in terms of accelerations?
MA in the direction of the friction.
Okay, in the direction of friction, do I have acceleration in the direction of friction? If you read the problem statement, it's moving at a constant
بالعكس
velocity. But it's moving at a constant velocity. Then I don't have any acceleration along the movement.
zero.
Okay, what is could there be any other acceleration that we have, or are we good here?
Normal
Normal.
acceleration.
Normal acceleration, exactly. Why do you have a normal acceleration? Because the velocity vector is changing direction, right? You're moving on a curved path, right? Okay, how would that look like? Where should I put that?
I think
Like
it should be to the
N.
center of the circle.
Hmm?
Shouldn't it be like to
مش
the
مثل
center?
N.
بس هذا مش circle, هذا y is a function of x. It's parabola.
It's like
It's in the same direction. It's in the same direction
perpendicular.
as n. Bravo. It is in the same direction as n.
yes.
Where is the point of application for that force?
Center of gravity.
Bravo. Center of gravity. All inertial acceleration will have the CG. ما هيك؟ هيدا هون CG تبعه. All right. So this guy is gonna go like this, right? And this guy is what? M times what? Times what?
V square over R.
V square over R. What is R in this case?
We get it from the formula.
Bravo, you got it from the formula. Exactly. Okay. Okay, so the problem statement بيسألونا انه to find n. How can I find n? How can I find n, guys?
بدنا نجيب ال MG components ولا لا؟
How can I find n? Basically, you guys remember? We have to sum the forces, مش هيك؟
أكيد بس بدل MG بدنا نجيب ال components.
لا, we just sum the forces along n, مش هيك؟ So if we sum, okay, so if we sum the forces
أوكي بيطلع
along n, شو بيطلع عندي؟
N equal MV square over R.
لحظة شوي. n بس ال mg عندها component along n, مش هيك؟ So we need to know this angle.
هذا أوكي.
How can I get this angle? Anyone knows? I think this angle here is going to be equal to this angle, right? هيدا is equal to هيدا, right? Let's call it theta. مش هيك؟ What is the angle theta? The angle theta, if you look here, right? The angle theta is هيدا الانجل, مش هيك؟ مظبوط؟ You guys agree?
I did not quite understand, doctor.
Yeah, the angle theta basically is the angle. So we're summing. We need to find n, مش هيك؟ So we're summing the forces along n. We're gonna end up with n. مظبوط. The mg we have to get هيدا component of mg along n. So it will be n minus شو mg times what?
Cosine.
هيدا
Cosine theta.
Yeah, هيدا theta is equal to هيدا theta, right? لأنه this guy makes 90 degrees. If this guy is zero, then this guy is zero, right? So هيدا وهيدا are perpendicular. هيدا line وهيدا line are perpendicular, مش هيك؟ وهيدا are perpendicular. إذا هون theta then هون theta, مش هيك؟ So n minus mg cosine theta, مش هيك؟
Yes.
Is equal to, guys, we have to move a little bit faster. Equal to what?
MV squared over R.
MV square over R.
Is that correct?
Minus.
Okay, minus, bravo. Okay, so we're good. So we need theta. مش هيك؟ what is theta؟ theta هي الانجل بين اوكي هيدا وهيدا which is this right؟ هيدا الهوريزونتال مش هيك؟
Yes.
Yes,
horizontal
80.
والcurve. How can you find the angle between the horizontal and the curve? So this is the horizontal and then this is the curve. إذا معك y is provided to you as a function of x, how can you find the angle between the horizontal line and the actual curve?
Tangent of the slope.
Tangent of the slope. Okay, yep. How so? كيف يعني كيف بتصير؟ So إذا أنا عندي curve right؟ إذا أنا عندي curve طالع هيك for example right؟ هيدا هون dx إذا بياخد small thing in small element right؟ هون رح يكون عندي dy هون رح يكون عندي dx مش هيك؟ So إذا الانجل هون theta so tangent theta is always equal to what؟ dy over dx مش هيك؟ So theta هي inverse tangent of dy over dx. إذا كانت positive it means that the curve is going to be going upward right؟ لأنه بكون dy positive إذا عم بيطلع مش هيك؟ dx is always positive as you move from left to right but dy إذا كان dy عم تنزل بتكون هيدا negative right؟ بتكون الانجل is below مش هيك؟ نحن هون we're looking at the absolute value of the angle مش هيك؟ Okay so let's find theta. How do I find theta? I need to do dy over dx مش هيك؟ What is dy over
Yes.
dx? It will be minus 40x over 6400 مش هيك؟ بس أنا I need to evaluate theta at what angle? At 80 مش هيك؟ Theta
Yes.
when x is equal to 80 is equal to the inverse tangent of minus 40 multiplied by 80 over 6400 مش هيك؟ حدا بيعملها ولا أنا I can do it here maybe. So 40 times 80 divided by 6400 is 0.5 مش هيك؟ So we need to do a10 of 0.5 or minus 0.5 مش هيك؟
Yes.
0.46 radian حوالي degrees. 26.3 okay so it's minus so طلعت minus 26.3 degrees. Does that make sense? We're good? Okay next step is what?
لا هي طلعت ماينس لانه الهوريزونتال اللي رسمناها فوقها ما هيك مش تحتها مثل تبعت الدي اكس دي باي.
So can I put this theta هون؟ هل minus 26 can I put that here or no? Should I put 26 or minus 26? Exactly. So minus 26 simply indicating a line is going down, right? So here we're looking at the absolute value هون of theta مش هيك؟ بهيدا الفانكشن. Right? We're taking the absolute angle هون. Okay, so it's gonna be n minus 800 times g times cosine of 26.3 is equal to minus 800 times v squared. What was the velocity? 9 squared divided by the radius. Okay, so we still need the radius of curvature. How do I find the radius of curvature? So r at 80 meter. مش هيك؟ r at 80 meter.
في لها فورمولا.
في لها formula. Okay. Do we need to do that? Okay, let's do that. Okay.
بس فيك بليز ترسم الكومبوننتس تبعون الدي اكس دي واي على الكيرف تبعنا الاساسي.
dx dy you mean what? Which dx dy? Here?
يعني على الكيرف تبعنا محل ما عم تمشي الكار ايه يعني هول الكومبوننتس اللي اخذتهم فوق مثلا على الاكزامبل تبعك فيك ترسمها على الريال فيجر.
Yep, exactly. So this is my dx, for example, and then this is my dy. This is my dx, and then this is my dy. You're looking at a very short element here, okay? So this will always work. Okay?
وين الثتا لك؟
Theta is here. Okay? Tangent theta is equal to dy over dx. Okay? Very simple. Okay, so we need to find now the radius at 80 meter. How can I find the radius? So we have this equation, right? So we're gonna do rho is equal to 1 plus dy dx, which is given to you as minus 40x over 6400 squared. The whole thing is over 3 over 2. And we do the second derivative of this is going to be equal to minus 40 over 6400 the absolute value طبعا مش هيك؟ So should radius at 80 meter is equal to we're simply going to put 80 at x, right? So 1 plus 40 times 80 over 6400 squared 3 over 2, and the whole thing is divided by 40 over 6400. So once you do this, you can find n. Okay, I'm not going to do all these calculations here because I will let you guys do it, but you know, pretty straightforward, just numerical computation here. All right. Is that clear, guys? Like, you know, how we set this problem up? What is really important to me on the exam that you have to be able to set this. هيدا أهم شيء أنا بالنسبة لي. For you to be able to set the problem, understand radiuses, understand what is actually happening. Okay, the other thing that we have is we have to find the frictional force. How can I find the frictional force?
We sum the forces along F.
Bravo, very good. Very well. So we sum the forces along F. I'm going to write it here just to keep it. To find the frictional force. Okay. So friction. So we sum the forces along F. On the exam تعمل لي هيك ما هيك you indicate the direction and then بتقول لي انه هيدا the positive direction مش هيك. So what should I write here?
Yes.
It will be equal to what?
F.
Okay.
F minus mg sine theta.
برافو. كثير منيح. Okay. Equal to شو؟
equal 0.
برافو. كثير منيح. Equal to 0 ليه؟ لأنه we don't have any acceleration along the curve, right? Or along the movement. So the friction is equal to mg sine theta. Okay, bravo guys, you're doing great. Okay, we're good. So we're done with this example. Okay, that's it. Okay, really simple. Just it's all about really understanding the free body diagrams, understanding the acceleration, setting this diagram, understanding how you can find theta, right? And you can apply this basically, you know, anywhere that you actually encounter something like that. Okay, we're done with the first problem.
exam كم question الexam?
Exam will be like, you know, 3 problems, maybe 3 to 4 problems.
ما كتير بيطولوا معقدين وهيك ما هيك.
No, just like this problem. I mean, just like this problem, you know, it will be something very simple. You know what I mean? Like just you understanding how you set the forces and then understanding the acceleration. All right. If you are attending these lectures and then are watching all of them offline, right? You don't have to, you know, if you're watching it, if you can make it online, obviously it's great. Some of you cannot make it here. But you know, if you are watching them and then doing all these on your own, and it's always a good idea that you guys, you know, work with each other, you know, try to bring problems and then solving it together is very good. You can kind of solve it online, basically. You can open up your own meeting. Okay, guys, let's work on problem 6 here. We have the block B, which weighs 200 grams or 0.2 kilogram, is attached with a rope, and it's basically rotating around here. Okay, it's rotating with its constant velocity of 0.5 meters per second. We need to find the tension in the cable and the cord and the normal force basically on this. We can neglect friction. So I'm gonna draw this for you guys. So we have cone like this, right? Okay, عندنا cone وعندنا على الcone basically we have like a box. Okay, وهيدا البوكس كان عم يبرم, it's rotating around the cone. Okay, so here it would be like that. Okay, so this guy is like kind of spinning around the cone, and we would like to find the tension in the cable. Okay, how can you find that? All right, we know this guy here is 0.3, and then this guy here is 0.4. Okay, can someone help me out to find that? How can I find the tension in the cable?
We need to do a free body diagram.
Bravo. You need to do a free body diagram. Let's do it right here. What's a free body diagram look like here?
بس شو هي 0.3 يا دكتور؟
0.3 is the radius of this.
radius مش الدايمتر يعني.
لا, it's provided to you here already. Okay. By the way, head distance من هون لهون is how much?
200.
Yep, 0.2 meters. Okay, how does the free body diagram look like on this object?
We have the weight vertically downward. And n perpendicular to t.
Bravo, exactly. So n is like that, right? Okay, very good. So we have the normal.
وهون ما we don't have friction here.
We don't have friction, exactly. Yep.
We have normal acceleration.
Okay, should I put it here, normal acceleration?
No. لا.
I'm gonna draw another diagram, right? So this is a block, and then this is the orbit, right? How do you think the normal acceleration is gonna look like on this block?
مش towards the zero axis.
Point to the center of the curve.
Here, right?
هون ما عندنا curve يمكن.
هذه هي M. Is that right? Is this correct, guys, or no?
لا, I don't think so.
No, it should be towards
No.
the circle that it's drawing.
لازم تكون مثل ما عم تمشي البلوك.
Yep, exactly. So مثل ما عم تمشي. So to put this, to describe this better, so you have to look at the plane of rotation, right? The plane of the circle. مظبوط. هي it's rotating in that
along
circle.
Z يعني لازم تكون مثل n. صح ولا لا؟ لازم تكون مثل n الدايركشن.
Should it be مثل n?
بحس هيك.
لا, it has to be like this. Okay.
along Z يعني.
Okay, so basically when you are looking at that, so you look at the axis of rotation. The axis of rotation هنا is basically perpendicular. So you basically always, when you're looking at the centrifugal acceleration, right? V squared over R, you always want to look at the plane of rotation. So if this object is rotating like that, this is the axis of rotation will always be perpendicular to the plane of rotation. The plane of rotation will be the plane in which movement is happening, right? So your acceleration will always be perpendicular to the plane of rotation, to the axis of rotation. And then this is your plane of rotation, right? All right, guys. Okay, so we're good. So we're trying to find the tension. How can I find the tension?
Sum the forces along the tension.
We sum the forces along the tension. Exactly. Okay, so how would that look like? So if I'm summing the forces along the tension, what do I end up with?
I have the tension and the mg component.
Bravo. Yep, exactly. So, okay, so I have the tension. So it's going to be T. All right.
T minus mg cosine theta.
Minus mg. Okay, what is theta in this case? So, okay, let's call this guy theta. You agree?
Yes.
I have 200 and 300.
بس دي شوي. إذا سمينا هيدا theta, right? Then this guy is going to be theta, مش هيك؟ Okay.
Yes.
If this guy is
في
theta,
ناس
then
تعمل التانجنت.
ما هي ذاته. اوكي, اذا هيدا تاتا then هيدا ام جي الكومبوننت تبعها that is along T is what? Sine or cosine?
Cosine.
Cosine, exactly. So cosine theta, right? If I use that theta, right? Okay, so we're good. What
Yes.
else is this is equal to what on this end?
كمان هون بجيب ال
هيدا التاتا مش هيك؟ So this is to some reference, right? هيدا التاتا مش هيك؟ Okay, then هيدا الانجل هون شو؟ إذا هيدا تتا
90 minus 90 minus ثيتا.
اوكي سو اذا هيدا زيرو هيدا شو بصير زيرو right لانه هيدا right this guy will become vertical this guy is always horizontal then this guy is theta actually right
يس بيطلع مثله.
okay so اذا هيدا صار زيرو هيدا رح يصير زيرو right okay so what should I write on the right side of it so I'm going to look at the vertical component of this guy along t مش هيك I'm summing the force along t is in that direction
plus mv square r sin theta.
exactly mv square over r sin theta. Literally, like the solution of this problem is a single line, right? Is this. What remains here is that we have to find theta and then we have to find r, right? The radius of at this radius of curvature basically of this movement. So what is t equal to? So t is gonna be equal to m مش هيك m g cosine theta plus v square over
v
r
square.
sin theta. Okay, I need you guys to, how can I find theta?
You know it's 200 the rope و 300 the radius. So
Exactly. So one thing we can do is we can say مثلا tangent theta مش هيك؟ Tangent theta is equal to how much? Opposite over adjacent مش هيك؟ So 0.3 over what?
0.2.
لا
0.4.
0.4 exactly. Less 0.2. 0.2 is only half of it, right? So this is all the way through, right? So this triangle is like this, right? لهون مش هيك؟ So 0.3 and then tangent theta is opposite 0.3 over adjacent اللي هي كلها 0.4. So theta is gonna be okay. So now we're good. We got theta. How about the radius? How can I find the radius? How can I find the radius is a distance, right? From here to here, right?
مش ثيتا times 0.2.
Okay, هيدا radius. You guys agree? I know هيدا 0.2 وعندنا هيدا theta, right? So I'm trying to find this length. What is that length equal to?
Sine minus 1.
Okay, so this guy is 0.2 and then this guy is theta. So I think هيدا رح يكون equal to what? 0.2 times sin theta.
Sine theta.
sin theta.
Exactly, or is equal to 0.2 times sin theta. So you have both of these. Now we're good, right? So we found theta, we found r. Now we can actually plug these in here and then we can find the tension. Really nice and then very easy. Any questions, guys, on this or? Okay, I think we have another question here. We need to find the normal. How can I find the normal force? Yeah, هي هيدا, right? This is a normal force.
We sum the forces on the normal line.
Bravo, exactly. So you literally, okay, finding normal force. So we're gonna sum the forces along the normal force, which is like that. Okay, what do I end up with if I do that? Okay, so I'm summing the force along the normal, right? So what am I gonna get? This is your normal.
You have the normal on one side.
Yep, exactly. So
n minus
okay, so
n minus mg sin theta.
bravo, n minus mg sin theta 100% with tension.
tangent ماشي لا هي لان perpendicular عليها.
Exactly, the tension, exactly. So I'm summing the force along the normal. The tension has no components along the normal, right? Excellent. Okay, so we're good. All right, equal to what?
تطلع equal mv square over r cosine.
A minus or positive? Minus, مش minus.
تطلع minus.
Direction as right? Minus mv squared over r cosine theta. Okay, we have all these information. We have theta and then we have r. So n is gonna be equal to m. So I'm gonna factor these out. M was put g sine theta minus v squared over r cosine. Okay, so if you notice a normal force هي mass multiplied by these guys have units of what? Acceleration. مش هيك؟ g sine theta is an acceleration وال v squared over r هي acceleration. مظبوط. normal acceleration هي v squared over r. Okay, so you notice in the whole basically they end up acceleration multiplied by the mass, the unit of force, so we're all good. Okay, so guys, this is what the exam is going to be about. If you understand the spirit of how you are doing this, how we're summing the forces in one direction, and whatever we are doing on the forces, whatever direction that we are using to sum the forces, we are going to use the same thing to do the acceleration, right? But here it's also important that you identify the right accelerations, what acceleration is actually involved here, and you also have to understand the geometric relationships that you are doing. So whatever theta we put here, you have to be able to set it up exactly in the right way. And I don't think this is a problem for you guys. This is something really, really simple, like understanding how put that does, etc. Okay, so just make sure you are practicing really, really well by solving all the homework assignments. Okay, if you want to do well in this course and you want to really excel, that you definitely have to do all the assignments. Okay, guys, let's jump into a new problem, and then this is going to be example 7. But what I'll do first is I'm going to actually close this meeting and then restart it, so we have another 20 minutes or so to be able to finish it up.
Doctor, I have a class. I have to leave?
Oh, okay, no problem. No problem.
You will post it today, right?
Yes,
هتنزلها اليوم.
that is going to be posted. Yep.
Thank you.
Okay, sure.
Doctor, please.
Yes.
The video stopped. There was an internet connection. Can you repeat how you get R in the last question, please?
Oh yeah, absolutely. So R here is the radius, right? The radius of the circle, basically, right? Or okay, so this guy is rotating, right? So first of all, you have to identify the plane of rotation. In this case, that slice here is the plane of rotation, right? And you basically have to identify the circle about which this guy is actually the circle that this guy is executing, and then we have to find its radius. So we know that this is going to be the radius. How do I find the radius? So I know this distance is given to me as 0.2 meters, and I have the angle theta. So this line is simply going to be equal to 0.2, which is this guy, multiplied by sine theta. I will actually get this value. Okay. Okay, guys, so what I'll do is I'm going to close this and I'm going to restart it again. Okay, so we have a new
Doctor, I sent you an email. In the exam time, I also have an exam.
So yeah, if you have a conflict with the exam, I've said that we will be able to do a makeup exam. So there will be 2 tests. If you can't make it, you will do another test.
Okay, doctor.
Okay, one, but one, doctor.
When it's gonna be, I'll let you know about it. Just basically the next available day, I'll email you about it. Okay, I'm still working out the schedule.
Okay.
Okay, give me. I think today I'll get back to you with that exact day. But okay.
Okay, thank you.
Okay, great.